So, can you hear me? Another? Boleh, doktor. Okay. Alright. So, probably how many students we have here? 23. So, I'll just start lah, ya. It's already 11:06. 6 minutes past 11. So, what we want to do today is we want to finish on the what we call that the Pareto diagram. Have you tried out the Pareto diagram? Buat tak dekat rumah? Dekat rumah lah. Ada try ke?
Ada.
Thumbs up. Okay, right. Probably we can discuss on that. Okay. Kejap ya. I think this one, let me share you my screen first. Okay. So try here. Okay, if you still remember, I asked you to try and develop the Pareto diagram. Okay, for this one, all right, the Pareto diagram. So probably we can we can discuss a little bit on this one before we move to P chat and C chat, right? So I hope that everybody can like try this out, right? So if we look at this one, this kind of question, what we need to do first is okay, Big Sundry and Berhad, okay, is a company that produces mango yogurt. So this is the product in a glass bottle. All right, so this is the packaging. Currently, this company receive a lots of complaint from their customer regarding a defect found on their products. So whether it's in terms of the package, we have two. One is the packaging and the other one is the product. Yeah. Okay. So number one, number two. So table 3 show the defect received from their retailers. Okay, so this is actually the table that show the defects received, okay, from retailers. Retailers is actually it's like a supermarket, all right. So probably they receive a complaint from a customer, so they just compile the complaint together, or even let's say based or throughout or during the handling process. So when they receive the products, they log into the complaint. Okay, so we have like the scratch on label as the defect. And then we have a dented container, number 1, number 2, number 3, number 4, number 5. So we have 5 defects, okay, like printing issue related to the expiry date and also the batch code. We also have the viscosity of the product. Customer probably complain about the viscosity. And also the last one is the swollen appearance of the container. So if you look here, compare with the one that we have last week, where we only have like a one, I mean like, you know, when you have like this one is a defect and then you only have like a one value for the complaints, okay? Comparing with this one, what you need to do is, because we have like a different day, like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. What you need to do is you have to total up first before we calculate for the percentage of each defects, and the other one is the cumulative percentage. Okay, so I think you've tried this one. Dah try kan dekat rumah? Dah try ke belum? Dah. Okay. So probably we can have discuss. Where's my calculator? We can discuss about sekejap ya, about the answer, and then later on we'll try to come up with the Pareto diagram. Sekejap. So if we look at the first one, okay, if you calculate the stretch on level, okay, add all the days, all the defects collected for each day. So what will you get for total? Kita tulis kat sini lah kot. Total you'll get how many? 2 plus 3 plus 9 plus 4 plus 2. Berapa?
20.
2 plus 3 plus 9 plus 4 plus 2. So 20 yeah, for stretch on level. Okay. The second one for dented container. Dented container berapa?
34.
34. Okay. And then printing issue?
39.
39. Viscosity of product?
7.
7.
And last one, swollen appearance?
7.
7. Okay. So total up, how many you have here?
107.
107.
107, yeah? Okay. So now, once you already have that, okay. Now what is the percentage? Wait a minute. Okay. The percentage, but by right, we need to calculate, we need to arrange them accordingly, right? So number one, I tulis kat tepi ni Number one would be for which one?
Printing issue.
Okay, this
Printing
one is
issue.
number one, printing issue. And then number two would be for
Dented container.
dented container. Number three would be for stretch level. Okay. Number 4 and 5, viscosity and also swollen appearance. All right. So now what we need to do is we have to calculate the percentage for each of the defects. Okay, so kat sini percentage ya. So the percentage, this is not the cumulative percentage. So the percentage for each, for example, let's say 20 divided by 107. Probably we'll start with 39. 39 divide with the 108. Apa? With 107. 439. Ini dapat berapa?
36.45%.
45. Okay. For dented container.
31.78%.
31.78%. And then the third one, stretch on level, 20 divided by 107.
80.69.
18.69 ya. 69. Allah. 18.69. And the last one, 7 divide by 107.
6.54.
6.54, yeah. So this one is 6.54. Okay. Now, probably, Okay, we'll take this one. Okay, let's try and wait, yeah, wait. Let's see. Okay. So we'll come up with the Pareto diagram. Check ya. Quick notes. Check ya. Check. Okay, so just now we have for number one is here. So by right, you should write like this. This one is the defect. Defect. And then number one, we have the printing issue. Okay. And then the second one, you have the dented container. Number three, you have the scratch on label. Number four is viscosity. And number five is the swollen appearance. Okay, here is the percentage. And yang ni I'll just put it here, 39, 34, 27, and also 7. So here we have just now 36 point, berapa tadi? 36.45 Is it?
Yes.
45, okay. And then 34, 31, right? 31.78, right? Betul?
Yes.
And then 20, 18.69. The last one, 6.54 and 6.554. Okay. So here the total would be 100%. Okay, now we have to calculate for the cumulative percentage. So now, when you have the cumulative percentage, for the first one, you'll have 36.45. Okay. And then, berapa? 36.45 add with 31.78.
68.23.
68.23 plus with 18.69.
89.92.
89.92. 89.92 plus with 6.54.
93.46.
and plus with 6.54. 100?
100.
Okay. Alright. So once you already have this, okay, and then what we need to do is now we want to develop the Pareto diagram. Okay? Boleh follow ke? Until here?
Yang
Yeah.
scratch on label tu, I think cumulative percent dia tu salah. Saya dapat 86.92.
86.92. Sure. Plus 31.78. Okay, plus 18.69. 86, yeah? Here. Yan. 86.92. Plus with yang bawah tu betul tak? 6.54.
Bawah tu
93.6. Alright. Plus with 6.54. Okay, yang ni betul dah kan?
Yang lain betul.
Okay. So, once we already have this, now we want to develop for the, what we call that? The Pareto, Pareto diagrams. Okay, so first of all, okay, the total here is, just now we have berapa total of the defect? 107, right? So 107, it should be around, example here, 107, and then probably we have another one. Okay, must be more or less equal with 100%. So this one is a cumulative percentage, and then this one is the, here is the number of defect. Yeah, number of defect. Okay, so because we already arranged accordingly, number one is the printing issue. Printing issue 39. So you just do like more or less lah, yeah. So here in between here is 53.5. 26. So here in between is more or less 27. Okay, should be like 50, and this one is 75 lah. Okay, so just now we have 39. 39 probably around this area. Tinggi sangat ke ya? And then you have like 34. And then 20. 7 and 7. Okay, more or less lah ya. So label them. This one, just write down in the full sentence lah. Full printing issue. And this one is dented container. Yeah, container. And then stretch on level, viscosity, and also swollen appearance. Okay. So when we have this one is actually 36.45. Tinggi lah pula. Kejap ya. 39, more or less here, I think. Yeah. Okay, so here is 36, and then we have 68 here. 86, 93, and 100, yeah. Okay. So now you draw the line, the curve, like this one. Okay, kenakan lah punya tu. Alright. And the next one, what you need to do? Once you already have this one, so what else you need to do? 80, 20%, yeah? So just drag this one, probably, probably it will, like, it depends on here. Here is 80, more or less. So it depends on your, apa nama tu? Graph lah. On your scale, yeah? Okay. So this one is the most important. And this one is the least important. Okay. All right. So we identify the printing issue, dented container, and also stretch on level is considered as the most important things. Important defects. Okay. So what you need to do now is actually, like for this kind of question, usually you need to come up with the preventive measure. So what should you do in order for you to, example, the preventive measures for, come up with the preventive measures for number one is a printing issue. Okay, what should you do? Printing issue, because we have just now the printing issue related to the batch code number and also the expiry date. Number two is a dented container. Number three is a stretch on label. So what are the preventive measures that you can think about in order to overcome this issue? For example, let's say for number one, apa? Is there any preventive measure in order for us to overcome the printing issue? Anyone would like to try? How to overcome the printing issue? Anyone? Hafni? Hafni ada Hafni? Hafni?
Doctor, can I try?
Yeah.
Maybe we can check the printer.
Check the printer. Okay. More towards the maintenance and calibration. Maintenance and calibrations of printing machine. Okay. Okay. Go back. Machine. All right. What else? For dented container. Okay. Number one, example, printing issue. Probably you maintain and calibrate the machine. Probably in terms of the maintenance, you can also mention about cleaning of the ink, ink printer. Okay. The printer under the maintenance. How about the dented container? Anyone who would like to try? How can we reduce the defect? How can we reduce the number of complaints in terms of dented container and also stretch label? So usually these two works together lah. You have to do what? In terms of dented container and stretch label. What should you do?
QC.
QC, inspection. Okay, inspection on the final product. Inspection of the final product. And the other one, probably, what? in terms of the operator. So we
Improve handling during production.
sorry, what is that?
Improve handling during
Improve.
production.
Okay, number 2 is improve handling. Handling during production. Okay, so production. So means that this one, number 2 is actually focus in terms of the operators, how they handle or during the distribution. So distribution means that during our handling, okay, whenever we want to transport from the factory to the retailers. So probably from there we can actually reduce the what we call that? Reduce the defects. Yeah. So for this kind of question, okay, in terms of answer scheme, the scheme, how we actually calculate, how we give marks. So if you have like the correct calculation in terms of the percentage, you have 1 mark. This one, correct calculation on the cumulative percentage, another 1 marks. Okay, this one, the what we call that, this one is the histogram that you develop, is another 1 mark. And then here consider as a half mark, another cumulative percentage axis is another half mark. Aku dah kat situ 1 2 3 4 4. Okay, here 1 and kadang-kadang dia boleh jadi 1.5, kadang-kadang dia boleh jadi 1. Okay, it depends whether you have like a 7 or 8 mark allocation. And then here is another half mark, here is another half mark. This one, the preventive measures, okay, if it requires 2 preventive measures, come out with 2 preventive measures, 1 mark each. Okay, so you'll have how many now? 1 2 3 4 5 6 7 and 8. So total Pareto diagram would be 8 marks. Okay, clear? So if let's say, if you receive these kinds of questions, you have to make sure that you calculate them well, because if you give like a wrong answer for the percentage and the cumulative percentage, it will affect. Okay, this one will be okay. I'm sure you can calculate directly, but some of the student might confuse or might calculate the cumulative percentage wrongly. So when you have like a wrong cumulative percentage, it will affect this one. You won't get marks for this one. And also you won't get mark for this graph. Okay, this one, this line. So inilah. Okay, any question? So this is how it looks like if you have to answer for Pareto diagram. Okay. All right. Any question? Can I move to next one? Yeah.
No, doctor.
All right. Let's move to another. Let's move to this one. Okay. We're done with this one. Okay. So we are already done for this one can. Okay, now what I want to do now is I want to continue with the control chart. Okay, so control chart. All right. If you still remember, I think like half of the class already do for the practical 3. We already discussed in terms of the control chart. We have the X chart and also the R chart. Okay, so basically, if I show you the control chart, is more or less look like this one. Like this one. Okay, this one is the control chart. Okay, but this one is the P chart. And even let's say if you have a B chart, we also have a C chart. This one is nampak sama je. C chart, P chart. But of course you have like a different equation to calculate the P, C, and also R and as well as X chart. Okay, right. So what we want to do today is probably we'll go in terms of the calculation for P and C chart. But before that, let's take a look at the introductions. Okay, the introduction would be for the here. This one. All right. So if we look here, in terms of the control chart, basically we want to monitor, okay, the ongoing production, so ongoing process. So it relates with the variables that we have for each of the products, and then we want to know whether we produce product within the range or not, within the spec or not. Okay, so whenever you talk about control chart, okay, you have these three things. Okay, because it looks like this one. This one is the control chart. Okay, and then you need to come up with the UCL, and then you have a UCL is the upper control limit. You have a CL control limit, or we call it as a center line, but usually we have we call it as a control limit. And then the last one is you have a LCL, so lower control limit. So basically, what we need to make sure is we have to make sure that our product is within the spec, in between UCL and also LCL. Okay, right. So it doesn't matter what kinds of variable we have, we measure, but it is more towards that we want to observe whether we produce a good product or a bad product. So what happened if let's say we produce a bad product? Bad product means that if we have like outliers can be over the UCL. Okay, for example here. Okay. Example, this one is the how it looks like. This one is actually our product, one product or two product, based on how many pieces we will take for sampling process. Okay, and then suddenly they have like this one or this outliers. So this one we call it as outliers. The ideal one is it should be in between this UCL and LCL. So what happened if we have samples or product that beyond the level, okay, or below than LCL? So is of course there's preventive measures that we need to take. Okay. So in terms of control chart itself, we have four kinds of charts. We have X, R, P, and also C. Okay, so X and R chart, okay, used for control of variables. All right, so we have like whether the parameters would be in weight, the pH, the total soluble solids, or a degree of Celsius. So we can use like X bar and R chart. So X bar and R chart is actually they have a relationship, because from X chart we can calculate the R chart. Okay, X means mean or the average, whereas R means range. Okay, so mean is more towards the average of the sample, but when it comes to range, it is more towards that we have to come up, we need to have like a few set of data in order for us to have the range. Okay, so range would be like from the highest to the lowest. So means that we have another one R chart, and another one is for the X chart. Yeah. And whenever you talk about like P chart and also C chart, it is more towards that we want to control the attributes, whether it's satisfactory or unsatisfactory. So attributes is more towards that we accept or we want to reject them. Okay, whether it's a good product or it's not good, it's a good or not good. Betul kan skip? Okay, please correct them. Effective or non-effective, or whether it's good or bad, heavy or light. Okay, so basically the comparison between P chart and also C chart. P chart is actually we want to measure the defect product in one lot. Okay, so remember a defect product in one lot. So it's like you want to make assumption that you want to conclude whether the products that you produce is accepted or is considered as a bad product. Whereas for C chart is more towards that you want to determine a defect in a single product. It's like this one is focused in terms of a single product. Okay, but P chart is more towards that. You have like a lot. So each lot, you can have like 100 or 1000. So it depends on the number. From 100, okay, we'll just take like 12 samples or 10 samples or 20 samples to represent the whole lot. So we can know whether we want to accept or not. Or from this control chart, you can know whether the sample is actually in between the range or not. Okay. So P chart is actually used for what? P chart used for what? Is it a lot or a single product? Mana satu?
Lot.
For lot. Okay. And for C chart is actually for single product. All right. Okay, this is actually the examples of X bar and R chart. Okay, they have like a different equation of to calculate the X bar and also R chart or R X or R chart. Okay, so as I mentioned to you, we have this UCL and also the CL and LCL. So this is actually the range, the spec, the parameters. We have to make sure that this is actually, if you look here, we have like a 11 sample. So we have a sample number. So sample number 1 up until 11. So we have 11 sample. So means that we'll take like 11 sample from the batch, particular batch, and then we use this sample in order to represent the whole batch. Okay, and as long as this sample is in between this UCL and LCL, your production is actually in a good one. So you have like a good production or process flow. Okay, so means you don't have any outliers. Kalau tengok kat sini, you don't have any outliers. Okay, so this one is more towards mean. Mean usually, example, let's say we'll just take like a week. Okay, this one is actually your variables. And look at the R chart. R chart is more towards that how it differ, how the value differ between each of the sample. It's like here is more towards mean, the average, but this one how it differ, comparing 1 and 2 and 3 up until 11. So how this differ? Okay, so if we look here, this one is the most perfect one lah, because it's on DCL. And then if you look here, this one and this one is it's not excessive, but it nearly to the LCL and also UCL, but still within the range. Okay, so this is actually the range. So R chart is with a range. All right. And this one is actually the example. Probably we can have a look at this one. Okay, I'll just use these examples and then maybe later on I'll ask you to do at home for the P chart. Okay. So now what you need to do is, okay, we have like it will be like a similar with the Pareto diagram where you have like a case study. So this is actually the case study where you have to work on the C chart or control chart, C chart or P chart. Okay, right. This one is actually the example for P chart. This question is kind enough because they mention here what kinds of chart you need to develop. Okay, so example, a manufacturer of an electronic control system for musical appliances. Musical appliances use a non-destructive. So non-destructive is what? Can you use back or it's considered as you cannot use back the sample? Boleh pakai balik ke? Boleh terus buang ke apa? Non-destructive means
Boleh pakai balik.
okay, so you can take back the samples. Okay, non-destructive testing, okay, to assess the quality of ECS. ECS is electronic control system. A lot, remember, a lot. So this one underline, a lot. A lots of 100 ECS is drawn predicate for testing. So after testing, the ECS will be classified either defective or good depending on the outcomes of the test. So this one is more towards the attributes. You want to know whether the whole lot is good or bad. Okay, so a lot here consists of 100. So 100 is actually drawn. Okay, from that 100, they only choose like 12 sample. Okay, so the following table gives the number of defect for 12 such sample. And here they ask you to establish a P chart for the process. So P chart for the process. Okay, look here. We have how many sample? 1, 2, 12. Okay, so we have 12 sample. And number of defect, we have 10 up until 14. So for these kinds of question, okay, because they ask you to come up with a P chart. So whenever you have the P chart, okay, you need to remember this equation. So this is the equation, okay, for P bar. All right. We have because even though you talk about like X chart, R chart, P chart, and also C chart, okay, they have like a different equation to calculate the UCL and also LCL. And even for this one, the P bar, if we talk about like C chart, you have a C bar. It's like this one, okay? And if you compare between P and C, you'll have like a different equation. So I'll just show you first. In order for you to calculate the UCL and also LCL for P chart, these are the equation, okay? The difference between UCL and LCL is just plus and minus. Okay, so they all give like a similar it's not similar number, the range. You mean like in between here and here, the value is similar. Okay, the range in between the UCL to CL center line and LCL to CL. So this is CL, this is UCL, and this one is LCL. So the range here is similar, sama. All right. Okay. So CL is actually similar with the P bar. Okay. So P bar here, you have like the sum of P. P ni datang dari mana? It actually comes from this one. Okay, number of defect just now. So you have like 10 plus 9 plus 8 plus 11 plus 7 plus 12 until 14. Okay, so whenever you calculate this one, okay, and then it will divide with the M. Okay, so M is actually M 12 times by 100 just now. Okay, so you have 12, yang 12 is a samples that you collect from this data, and then 12 sample, and then 100 is actually the lot size, this one, a lots of hundreds. It doesn't matter if you have like a 200, 300, 1000, so you just need to remember the equation. So this equation is actually for the CL, the center line, or we call it as a P bar, right? Or we call it, sometimes we call it as a control line, so control limit. So whenever you calculate the P bar, okay, you need to use this P bar in order to calculate for UCL as well as the LCL. Okay, so remember this equation, okay, P bar plus, okay, yang ni pula tak. So P bar okay, plus 3, ingat remember this one, 3 times, this one is times ya, kali, times, bukan 3, it must be times. So search with the rest of this value, okay, So N here is 100, your sample. Okay, so this one is 100. Okay, right. For example, let's say if you want to calculate for this one, what is the total of this one? Please calculate the total for 10 plus 9 plus 8 up until 14. So how many you get here? What is the number of defect? The total number of defect. Berapa? Buku apa dah ni? 950. What is the total number of defects?
$126, doctor.
Okay, 126. Okay. And then, so to calculate the P bar, right? Sure. Okay, so to calculate the P bar, just now we have, mana dia? Kat sini kan. P bar is, P bar is equal to sum of P divided by M. Okay, so M here is actually, we have 126, yeah? Divided by M is 12, okay, times by 100. So, how many you get? Berapa kat sini? Dia akan dapat berapa? 126 bahagi dengan 1200.
0.105.
0.105. Okay, so 0.105, if you look at the graph here, okay, here 105, sini, the center line, 0.105, this one, this line, so it's equal to CL or the P bar. Okay, yang ini, line ni. So this one is actually 0.105, in between 0.12 and also 0.09. Okay, so that one is a P bar. So now what you need to do is, once you already have the P bar, we want to calculate for the UCL, this one, the UCL and also LCL. Okay, so you already have the number 0.105. Okay, so what you need to do now is to calculate the UCL is equal to P bar plus with 3 times, yeah, this one times set with the P bar ni kira divided by N. N is 100. Okay, so try to calculate how many you got for the how many you get for the UCL and also LCL. Apa tak? Sini adalah 0.105. Okay, plus with yang ni tadi kita kali 3 times berapa? Setkan sini 0.105. Okay. Dapat tak? Calculate please. Dapat tak? What do you get for UCF? Dapat ke tak?
Tengah kira.
Nak kira Tak apalah. Kira sampai kira-kira tu, kira sekali dengan UCL, LCL, probably we'll take a break like a 5 minute. Okay? Sekejap lagi kita sambung. Like 12:03, something like that. Check in. Okay. So, all right, yeah. Let's continue. I think while you are calculate your UCL and LCL just now, we consider that one as a break lah. Okay. So you have the UCL is 0.197. Okay. And then the LCL is 0.013. So if you look here, the UCL will be here around this one, this area, 0.197, 0.197. And for LCL is 0.013. Okay, it should be in this area. Okay, so please remember in terms of the this one, the equation. All right, for this equation, okay, is not too complex for you to remember, but probably some student they will confuse with this one. Okay, so sometimes yeah ini just so during the exam or test they tend to uh they cannot remember well this one, so they tend to change whether it's 1 minus with p bar, uh p bar minus with 1, so it will give like a wrong answer. Okay. Okay, once we've done with that one, the UCL and LCL, okay, we have the CL as well. This point, okay, from number 1 up until number 12 is actually the sample number. So this sample number is where you have to look at this one, okay, and then for example, let's say because we have like a lots of 100, so it must be divided with the 100. So 10 minus with the 100 you'll get like 0.1. So this one is equal to 0.09. Up until here you have like 0.14. So you plot from sample number 1 up until sample number 14. So for example, this one, okay, you'll have like the 0.10. Okay, you just divide all of these numbers with the 100. So that is for the P chart. Okay, so once you have this one, then you plot, and we can actually connect one line, one plot to another, and then you can look at the trend. So the control chart, where we talk about like the R chart, X chart, P and C chart. All of this chart is more towards that we want to know about the trend, and this control chart is actually control chart. Control chart is similar with the SPC, but the SPC is more towards that statistical process control. Well, this one is more towards the automatic one. So you have like in the industries, like we are not going to spend our time to develop the control chart, but what we do is in terms of measuring the weight or any variables of the products, okay, we already have like a software, and then for example, let's say you want to measure the weight, we have to measure the weighing balance that connected to the computer. So automatically after you weigh, the graph will come up like this. So it is actually easier for you to monitor the ongoing process. So this is more towards the ongoing process. Okay. Right. That one will be for the P chart. Okay. Don't worry. I think I have one examples that we can do after this, but I would like to go with the C chart first, which is C chart is more direct because if you look at the equation, it is more direct, like this one and this one. Okay. Comparing with the P chart just now, because P chart is more towards that we want to measure defect in a lot. But for the C chart is more towards that we want to measure a defect in a single product. Okay, so you'll have like a single product which is focused on, and also, like whenever we inspect for the single product, so the number is like a bit lower. Okay, comparing with the lot is like actually you draw like a inferences or the conclusions towards the one big um lot, one big lot lah, one big number. Okay. All right. If we look at this one, this is the examples of control chart. Similar just now. We have a case study here, and then this time is actually there's a manufacturer of a color television that has a final inspection. Okay. So remember, for control chart, whether it's a control chart or P chart, usually it involves with the final inspection and offline inspection before the product is packed for shipping. So the final inspection involves testing the television on several parameters, which is actually identify any kinds of defect on a single product and verifying if the set performs satisfactorily in all the tests. Okay, it is possible that every television may fail or to fulfill all the parameters. Therefore, a C chart is used at this stage to control the process, because C chart is actually, as I mentioned, is for the single, yeah. Okay, so periodically 10 television sets are drawn for testing, and the table below give the performance during one such test. Means that for each of the sample, you have this data. Okay, so the question asks you to set up a control chart. Yang ni pun dekat cakap what kinds of control chart that you need to develop, but luckily here a C chart did I mention. It mentioned here is that you need to actually come out and develop the C chart. Okay, so we have a number from number 1 to 10 because we will take like a 10 samples, and each sample they have their defect. So we collect data for this one. All right, now what we need to do, first of all, okay, similar, this is actually the chart, yeah? This is the chart. But I just want to show you how to calculate, how to find the C bar, P bar, UCL, and also LCL. Okay, first of all, we have the C bar, right? The C bar, this one, you need to remember. Sum of C divided by M. So this time, the sum of C is actually what? You have from number 1 to, from number 1 to 10, okay? So we have to add, we have to sum all of this, 11 plus 9 plus 12 up until 6. So how many? Berapa ni? 11. Please calculate done. 11 plus 9 plus 12 plus 9 plus 12 plus 22 plus 7, 10, 3, 13, and 6. How many? What is the sum of C? This one is C. Sum of C equal to
111
100
and 11.
111. Okay. All right. So now 111. Okay. We need to divide with, okay, what is the M? M berapa sekarang? The equation just now is sum C divided by M. So M is 10. Okay. So 10. So you have 111 divided by 10 equal to 111 divided by 10. How many you get? Berapa? 11.1. Dapat tak? So 11.1 is the C bar or equal to center line. So you have the, here, you have the 11.1. So this is actually the CL or C bar for 11.1. Okay. The C chart is quite straightforward, quite direct, because once you already know the C bar, okay, just fill in the equation and then you can calculate for the UCL and also LCL. And similarly with the UCL, okay, the equation is like C bar plus 3, okay, times by slit C. So you have the LCL is like C bar minus root 3 times by set C as well, set C bar. Okay, so I'll give you like berapa minit? Lama pula. 2 minutes, 3 minutes to calculate for UCL and also LCL, and then you can actually write down in the chat box. Yeah. So calculate for UCL and also LCL. Tahu macam mana nak calculate the UCL here? More. UCL is so what is the UCL? The value for UCL and also LCL. Siapa ni? Oh, baru nak panggil nama. Fakira 21.09 and also UCL semua orang dapat ke ni? 1.105. Okay, 21.09. 1.1. Okay. Alright, so this one, the UCL here, okay, the UCL, this one, the UCL is equal to 21.09. So if you observe here, it's more or less atas sikit lah, above 21. Okay, and the LCL is here. LCL is equal to 1.1105. Oh, 105 lah. Right. So if you look here, probably is betul ke? Semua orang dapat ke? Semua orang dapat? Thumbs up, thumbs down. Thumbs up. Okay. Alright. Okay, so here you got the 1.105 for LCL and the UCL is 21.09. Okay. Now you already have the range. You have the upper and also the lower limit. And directly straightforward, we need to plot the sample, the defect for each of the sample, where we have just now we have 10 here, okay, and then you just plot like 11, 9, 12 up until 6, because this one is just direct. You tak payah bahagi, you don't need to divide with 10, okay, because this is actually a single product. So single product will just do in a single product, like you actually observing each of the product, okay. And then 11, for example, 11, this one is 9, okay. So we have this one, and then okay, I'll just erase this one first. Okay, what you need to do is, if you look here, we connect this plot, the dot, okay, and then the range is in between this one, UCL to LCL. But we have one alias. So alias is like if you have any point excess or more than UCL or lower than LCL, that one is considered as a defect. This is actually a defect because it goes beyond than the UCL. Okay. Mm, so of course, in any case, if you have this is not critical because you only have like a one. It's like 1/10. But if you convert, you'll have like a 10% of defect. So if you produce like 1,000 bottle, you probably have like 100. Is it 10%? Yeah, 100 bottles of defect, which is high. Okay, so by right, you need to have this one. This point is in between the line. So maybe from here, there's a few preventive measures that you need to take. That you need to take a look because this is actually a result changer preventive measure. So PM would be a common one. It's like maintenance or calibrating the what we call that the equipment. Okay, or probably there's certain process that you need to review back in order to reduce the defect. So because this is actually more towards the variables whether you accept or you reject the whole, because for control chart you inspect the whole the single product itself. Okay, so in one finished product you'll have like a different parameters. Okay. So parameters that you will have here probably because from a different process. So you need to think about the PM from a different process. Okay. Any question for C and P chart? Any question? Any question for C and P? I'll share with you later on. There's another calculation that you can work on. Probably you can try it at home and then maybe next week we will discuss. But next week I'm going to go with the topic 4. Okay. Is there any question? Okay or not? Understand? Don't understand? Thumbs up, thumbs down. Okay. Alright, yeah. I'll move to another one. Okay. Alright. So now let's look. I just want to finish QE because your test would be from chapter 1 until chapter 3. Okay, right. So the next one, we've done with the calculation. So we only have like 2 calculation. One is for control chart, the other one is Pareto. So we've done with that, alhamdulillah. Now, we are going to look at the fishbone diagram. Okay, as I mentioned to you, fishbone diagram. We have like 3 names for that. The Ishikawa diagram, okay, because it's actually originated from this philosopher Ishikawa. And then we also call this fishbone diagram as a cause and effect diagram, okay, because it measures the cause and the factor that contribute to a certain problem. And then you have the fishbone diagram itself today. Okay, so we have 3. And from here, a fishbone diagram, we can actually track the factor or any causes that contribute to the one main problem. Okay, so from there we can it can actually help to come up with the preventive measures. And this is actually the examples. So cause and effect. Kenapa dipanggil cause and effect? So effect probably because of, when we talk about like quality, okay, reduce the quality is very general. Okay, the statement here is very general because reducing quality is like it's very general. It can contribute by a different factor. Okay, so that is the effect. Effect is the consequences. And then if you look here, the bone, here is actually the bone, and this is the head. Okay, the main problem. So it's considered as a main problem. And then we have like different causes that contribute to this problem. If let's say we talk about reducing quality of the product, is very general. If let's say you want to talk about increasing the waste of packaging material, so that one is more specific. Okay, increasing the waste of packaging material. So this is more specific because we focus on packaging process and the wrappers. Okay, so packaging is a process, and also the material, and probably the operators. So maybe we have like a three here. So you have like a common causes that can contribute to this problem is like, environment. If you talk about like packaging, of course it won't relate with the environment, but this one is actually the generic one. Okay, generic, which we can use this fishbone to any problems that we face in food industries. And then you have a material, for example, let's say just now we have a packaging material. If you want to talk about how to actually reduce the waste of the packaging material method, because of the machine, okay, and then maintenance of the machine. All right, these things considered as a main causes that contribute to this problem. Okay, but if let's say we want to go or we want to look deeper, so you have another causes that contribute to this method or man. Whenever you man is like the operator lah, operator. Okay, whenever you want to talk about the main man or operators, the most important one is probably the skill. Okay, training. So this skill and training can be considered as another causes that contribute to incompetence handling. All right, towards the packaging machine. So that's why it will increase the waste. All right. So fishbone diagram is more towards that we want to track in we want to dig deeper what is actually caused the problems. Okay. And this is actually the common one. If you look here, it's similar with the previous one. For manufacturing, maybe you talk about like manpower. Manpower is the operators, the workers, methods, machineries, and materials. Okay. And for administration and planning, you have the equipment, policy, procedures, like SOP or working instruction, okay, and people. So this is actually belongs to method just now. Okay. Equipment relate with the machine, and also like a manpower. So they actually relate with each other. This is the examples. If you want to look in terms of the fishbone diagram, okay, we have like materials, method, environment. This is the big one. So these are these considered as factors. If just now I mentioned about men operators, okay, they are actually contribute or affected with the skill and also training, attitude, and also experience. So this one is actually under men. Whenever you talk about like machine, probably because of the technology, because of the fixtures, because of the variabilities, tooling. Okay, so these are considered as things that will affect the quality of the products. Okay, or probably increasing the waste of packaging material. Okay, so that one would be a little bit about the fishbone diagram. And last one, this one is actually the SPC. SPC is related with the control chart just now. We already discussed, we already learned how to how to come out or how to develop the control chart. Now it is more towards that we want to know the trend. Okay, so if you look here, we have like several SPC, we have a several chart that the common one, like this one and this one. Okay, we have like 8 types of control chart. This is more towards a trend. Okay, this is a common one. Like you have a excessive variables, you have a normal, high, trend, random cycle, while outliers, recurring cycles, and abnormal uniformity. So for example, yang ini ni is more to suit the one that would be here. Okay. So if let's say we go for SPC number 1. Okay, SPC number 1 is more towards what kinds of trend? Trend dia dekat sini. Okay, so if you look at the first one, is SPC number 1. This is more towards like a normal one, normal trend, right? Because the data is actually plotted in between the UCL and also LCL, and it's nearly towards the center line. So any data that, you know, like when we come up with the graph, when we develop a graph, and then the data is actually near towards the center line, that one is considered as the good process. Okay, so means that you have like you actually produce like a uniform products because you don't have any outliers that goes beyond than UCL or below than LCL. So you don't have any outliers here. So which considered as a good product, a good process. Okay. Whereas when you look at number 2, SPC number 2, it's still in between the range, okay, between this UCL and LCL, but the cycle is like, how to say, sometimes you have like the high one and then the lowest one, so it's not balanced, but still in between the line, okay. So this is more towards like still normal, but nearly to somewhat outliers. Okay, if it goes beyond than this line, this point will consider as the outliers. And then if you have like a SPC number 3, the trend starting the production, so it goes from upper to lower. So this one is considered as a down. Okay, trend dia ke down, a downtrend. And then here is a just covered in between the CL to UCL. This is high, only covered. Okay, only cover this area. And then if you have these kinds of trend, similar, yeah? This kind of trend, because this one is going down, and then it might probably go down then LCL after this. Okay, so there must be like a PM that you need to come up with. And this one, okay, still similar. This is actually similar with this one just now, but this is more to a bit harsh. Okay, and here you produce like a lots of outliers, so you need to stop the productions, and then you need to maintain and calibrate back the machine. And this one similar, okay, just for a few points. So this one is more towards like after sometimes you have this, but the rest is actually good because it's near to the CL. And the last one, the SPC number 8, is more towards that we can call it as still normal, but sometimes, you know, like if you look, this one is more towards like a recurring cycle. This one is more towards that it's not abnormal. This is more towards abnormal, these two. Yeah. Kejap tinggi, kejap rendah. So of course, whenever we observe these kinds of things, you need to stop the productions and then look at the process that contribute to this. problem. Okay. And we already covered about this one. About the control chart, what you need to do is we have to come up with the UCL and LCL, and we also have the center lines. Okay, so basically we have two. One is for variables, the other one is for attributes. So variables X and R chart, attributes is for P and C chart. Okay, so this is actually the overall of the use of tools. So specific diagram, so specific tool, we have 7 here. Okay, number 1 to 7. So each will indicate the functions of tools. If you look at the Pareto diagram, the one that involved with the calculations and also control chart here. Okay, they are actually more towards the problem identification and data analysis. And last one is the result evaluation. So result evaluation and solution planning is more preventive measures that we need to take. And then control chart here, data analysis, because we want to calculate the trend as well as what happened if we found that the product that we produce, the finished product that we produce, contain like outliers. So what should we do? Okay. And the last one, like statistical process control, which originally come from the control chart. So they are more towards sama juga more or less it seems like the Pareto diagram and also control chart, yeah. So that one would be the tools for the QA. So I think we've done with the QA tool, yeah, which is critical for you guys. Any question that you would like to ask me about the tools before I leave you for you to work on this examples. Okay, bukan example you need to do the calculation dekat rumah for C chart and P chart. Okay, don't forget to fill up the attendance form here. Just attach one more time. Okay, is there any question about the tools? Any question? Any questions? Okay, all right. So probably last one before we finish today. Yeah. Probably you need to take this one. Okay, take this one. Yang ni you boleh snapshot je. Yang ini. Okay, I have two questions. I have two case study for you to work on. Number one, this one. Okay, yang ini dia baik je. We have the control chart. Okay, chocolate Sandrian produce chocolate milk as one of their products. So a lot of 100 chocolate milk is run periodically for testing. It's very straightforward. Senang dia soalan ni. So probably please do this as the exercise, okay, later. Or you can do like, you can do the calculation, remind back to refresh back what you learned for C chart and P chart. Given in table 1 are the numbers of defect for 11 examples and establish a P chart. So this question is kind enough. Why kind enough? Because they already mentioned what kinds of chart you need to develop. So you just remember the equation. Okay, P bar is equal to this one minus by M, and then the other one is plus 3 Z, blah, 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 right? And this one is for the P chart. Okay, but remember, sometimes in the final exam, in your test, it won't give you any hint. Or this one is like a hint. You can just like come out with the P chart. Okay, they just give you like this number and this number. So you need to know which one is P chart or C chart. Alright. So yang ni dah ambil gambar ni. Dah. Control chart for this one. Dah Okay. Snapshot je. The second one. This one. Okay. So a final product screening has drawn periodically by testing by QC team. After testing, the log will be classified either defective or good depending on the outcome of the test. So table 2 gives the number of defects for 10 sample. It's like this one. Establish an appropriate control chart. See the word, the keywords of appropriate. So it's like it doesn't give, it won't give any P chart or C chart for you to develop. You have to think about it. And whenever you look at these kinds of question, okay, the hint for this one is C chart or P chart. This one is C chart, yeah. So you just remember for C chart, it will just give you like a one value, 10. But yang ni take the picture, and then this one develop the C chart. This one just now, kejap ya. This one for P chart you have two value, 100, and this one 11. Okay, so you have like 111 to indicate the P chart. This one for C chart, you only have like one value. Okay. So, any question for P chart and C chart? Yang ini balik, bukan balik lah, dah balik pun sekarang kan. So you need to try and do this exercise at home lah. Cuba ya. Any question? Or if not,
Doktor, saya ada soalan. Nanti kalau kita jawab soalan ni, kita kena plot yang chat yang macam contoh dalam slide tu ke yang
betul?
kena plot full lah?
Yeah.
Okay.
To see the trend. So sometimes after you need to, okay, like example here, establish an appropriate control chart kan. Okay, you come out with the control chart, and then what you need to do is usually there's another question that will ask you whether the process is in control or not. So it's actually you can determine based on the points that you plot in between the UCL and LCL. Okay. But these questions also consist of more or less like 7 or 8 marks. Sama juga macam Pareto tadi. Okay, Putri.
Okay, doktor.
Alright. Any more questions that you would like to ask me before we finish for today? So you just go home, go home dah memang duduk kat rumah pun kan. Try to come up with these two types of chart, yeah. So if you don't have any more question, I think don't forget to fill up the form, attend the link, and then I think